So 3D printing with nylon carbon fiber. Woof, what a year. We've had actually 2 new materials specifically for carbon fiber come into the Method platform. It's been definitely my favorite material of the year. Why? I'll talk about it a little bit, but it's, plain and simple, super strong, super straightforward, really, really, really had a blast with it. My name is Felipe. I'm the creative director here at Makerbot. I also get to play with the printers a lot. That's luckily one of my, or a section of my job description. Basically, I get to push the printers a bit. I get to design stuff for the printer to print, and then, basically test it out for you guys to know, to find out, what are the potentials of the materials, what are the limitations, what are the best practices sometimes, and just, trying to give you guys as much information as possible for you to make an informed decision. But yeah, it all comes down to playing with the printers, which I really, really, really enjoy. Who are we? Well, it's, we've been around for quite some time now, a little bit over 10 years. Makerbot has changed a lot through all those years. I've been at Makerbot for about 4 of those, over 4. And yeah, now we have a really nice lineup, which I had the pleasure to work on creating for professionals, and also it's being used a lot in higher education and in some education settings. But basically our Method platform, or what we call the Method platform, it encompasses what we refer to as, it's three main models: the Method Carbon Fiber Edition, which we will be covering today, and the Method X. The Carbon Fiber Edition stands more for, it's either the Method or the Method X, but it comes preset with everything that you need to get started with carbon fiber, essentially the material and the relevant extruder for you to get started specifically with carbon fiber. We've had a lot of luck throughout the years collecting quite a few names on our user base. We're really happy to be working with them. Anything from Peloton, KUKA, Toyota. Recently we did a case study with NASCAR team, LFR. Really happy with that. Lockheed Martin as well. So yeah, happy to know that the printers are being used where we expect them to be using, like in professional settings, and also for anybody just like myself who likes to push a little bit the envelope of what can be done with 3D printing and enjoys the process a little bit more. Today's agenda, it's basically everything carbon fiber, an introduction to get started, some of the applications out in the field, both for general carbon fiber and 3D printed carbon fiber, technical specifications of our materials. We have 2 versions. We have nylon 6 carbon fiber, nylon 12 carbon fiber. We will be talking about what the differences are between those 2 materials. Some of the best practices for 3D printing with it, orientation, how to use support, how to slice your parts, what are the tool heads requirements on the printer. By tool head, I mean the extruder, which I have. Where did I leave my extruder? Oh, here we go. The extruder, for you to print with carbon fiber. Why do we use a dedicated extruder? What are the changes and differences between our 1C extruder and other extruders that you might see us using with the Method platform? And of course, at the very end, we'll open it up for Q&A. If you have any questions throughout, do send them out. Alejandra, as I said before, in the chat, she'll be monitoring all of them, and we'll be trying to answer as many as we can, either through the session or at the very end. I see more people coming in, so that's also super exciting. Welcome, everybody. And let's get started with a little bit about carbon fiber. I'm sure you heard a lot about the material. I remember the first time I got exposed to carbon fiber was actually while playing tennis. It was my first, well, not my first, but like a second racket that I had. And I was just impressed by the sheer strength and lightweight properties of the material, right? So it's used a lot in anything from automotive, F1, some even actual production cars have now carbon fiber on it. As I was saying, sports, bike industry, Aerospace Parts. This actually, this photo comes out of SpaceX, one of their fuel tanks, pretty massive as well. There are many ways to actually produce, manufacture, and use carbon fiber. We'll be talking about one of them today. Super lightweight and compliant parts, but also parts that are really resistant to certain types of stresses. In this case, a bicycle, incredibly light options because you can create, specifically talking about bicycles, which I love, hollowed out materials, geometries that are really strong, even though they might not carry a lot of weight. So, the frame in this bike, we're talking about probably 2 or 3 pounds maybe. So really impressive to interact with those materials. Now, more often than not, when talking about carbon fiber, the main process, and specifically for the bike industry, we got this photo from a bike company called Uno. The process to make those components is basically to lay it up. It's more, it's closer to fabric, to clothing fabrication, where basically they lay out the parts and they assemble it using different types of molds, right? That's a traditional type of fiber where it's literally a fiber. It comes out as a woven material. And then, as the process goes on, you can see the part actually taking shape from these flat sections that you see laid out. So basically what you see on the center is the bicycle frame, that Uno frame. And then everything around it, those are the little layouts, not layouts, the little flat components that will eventually become that frame, right? So it's a very labor-intensive process. It's very complex, and there are different requirements. Specifically, the main one when using textile, I will refer to as textile carbon fiber, is the types of resin that you will use, the way that you will lay it up. It's also really important. How those threads actually interact with each other will make a difference in the stiffness and the strength of your final part. Also, we see it used a lot for shop tools specifically, and I have this part right here. This photo is from one of our customers, All Access out in Texas. And what they did was they wanted to have a very light option for them to support a dual tool head on one of the robots, right? So what they created, or what they came up with, is this really interesting part that basically gets nested or held by their automated 6-axis robot. And what it does, what it allows them to do, is to have 2 tool heads. In this case, it's 2 different grippers. So if you can imagine, like, one gripper comes here, like my hand is sort of simulating, the second one at an angle, so that they can have multiple actions with the same robot. And at the same time, they wanted to have a part that was fairly strong to be able to actually hold those grippers in place, but at the same, reducing the weight so that the robot wouldn't be under so much stress as it was moving. So couple of things that are happening here. First off, you can see that the hollow part, it's a very interesting geometry that they came up with. And at the same time, something that actually allows them to use that complexity, added possibility of geometrical complexity for the part. Also replacement parts. This one I printed out here. I got with me a little propeller, carbon fiber propeller. This was more of an exercise for me to show the types of complex parts that you can get. And that's where 3D printed carbon fiber really starts to break off from traditional carbon fiber. When talking about 3D printing carbon fiber, of course, you expect not to be as limited as you would with what I was describing for the types of layouts that and layups that you have to follow when creating or when working with fiber or fibrous carbon fiber, right? With 3D printing, the promise, of course, is that you will be able to create unlimited geometries, and you're not bound by either a mold or an enclosure or any sort of guiding mechanism that will limit the amount of freedom that you have, geometrically speaking. So with method and with 3D printed carbon fiber, what you achieve essentially is that freedom, right? You are able to use the material in a much more, I might say, advanced way, complex way, which is super exciting, right? It's not only the fact that you're using a really impressive material, but you're also getting much more freedom than what you would traditionally speaking. However, it does come with certain asterisks, right? It's definitely, there's more freedom, but there are considerations to make when actually 3D printing and when thinking about what are the actual possibilities with carbon fiber. So let's get started with some of those. Of course, now, carbon fiber represents just a section of the materials that we can use with Method, and specifically with Method X. Just last year, we introduced 24 new materials, out of which 2 of them are the 2 nylon carbon fibers that we will be talking about today. And I said it at the beginning, it's just such a nice material to work with. It has a really nice mix of being incredibly strong, incredibly light, and at the same time, specifically for nylon 12, and I'll talk about the differences between those two in a second, but it's just so easy to print. It's, I had a blast with ABS when we first introduced it to Method, but nylon 12 is just that it's just on a league of its own because of what you can do with the material, and then also the possibilities and the ease of use of the material. I know that this might be something might be new for some of you guys if you're just getting started with 3D printing, but there's definitely differences in the materials that you print. They will behave differently, and some of them can be a little bit more tricky to print with. Specifically, for example, I can think about polycarbonate. It does require a super high temperature to print with. You can achieve it with Method, but then some of the post-processing elements just become they ask a little bit more time for you to get the proper results. With carbon fiber, I've been with nylon 12. I've just been super surprised and super happy with it. Now, 3D printing carbon fiber, right? How does it happen, and how does it actually become or the printing element that we are using? First off, we chop the carbon fiber into the yarn itself is chopped into little parts of powder essentially. We mix that up with a base, in this case, a polymer base, which is nylon. That's why I keep referring to the nylon 6 and the nylon 12. That's the base behind our nylon carbon fiber. And finally, it gets spooled, and it becomes what I got here. It becomes my actual yarn, my actual spool, the one that I will be using to print with in my printer, right? So we got, often we get the question, like specifically when talking about 3D printed carbon fiber, there are two main types of carbon, and I think I have that in a following slide. But it can either be chopped, which is what we currently use, and it could be also single thread. When you're talking about single thread carbon fiber, what essentially is being described is you're getting a single thread of carbon fiber, which is enclosed in that same base polymer, right? So it follows a similar logic. The difference is that the thread actually has a single orientation to it. For some applications, that might be better. For some others, it might not be. In this case, the chopping actually creates a more even, I would say, distribution of the carbon fiber, but it all comes down to the actual technical specs, right? How does it behave? And specifically our carbon fiber, how does it compare to other materials, and what are the physical properties that you will be getting out of it? Talking about heat deflection, right? If you compare it with all of our other standard polymers, PLA, PETG, ABS, even nylon, you're getting almost twice as much resistance to heat deflection as you would with any of the rest of the materials. So, you're going almost to 200 degrees Celsius. That's rather hot if you consider that, 100 degrees Celsius is about the boiling temperature of water. Any one of these parts will take you all the way to 184, just about. So close to twice, or a little bit over twice as much as the next best material, which essentially is nylon. That's one of the reasons why we chose nylon as a base polymer. And then when talking about the tensile modulus, you're also getting an impressive increase in performance, right? Almost 3 times. You see PLA, these are all megapascals. So PLA, PETG, ABS, nylon. Now, one of the interesting things here to know is that you would probably, at a glance, you would assume that maybe PLA, if just comparing like the most standard polymers here, PLA and ABS, PLA might be a little bit less strong than ABS. However, at least in my experience, and this is one thing that I was wondering when I first saw these numbers, what happens with PLA is that it's a much stiffer material for some reason when it comes out of the printer, right? And I know that we've all stomped in a Lego brick, and we know how strong ABS can be because of that. But definitely an interesting material that sometimes gets underappreciated, PLA. But it all depends on the application, right? That's another thing to consider. What am I trying to print? Am I trying to print something that needs to be super lightweight and strong? Am I just printing a quick prototype? Am I just doing a mock-up of something? And then if I'm looking for the strength, the lightweight, and the super impressive material qualities that carbon fiber offers, then definitely you can see the difference, the stark difference between any other polymer and the nylon carbon fiber. So almost 3 times as strong when tested against them. And then this is what I was trying to get to at the beginning when describing the different types of carbon fiber and how, the different manufacturing processes will yield different results and will have, because of that, different considerations, right? So when we're 3D printing carbon fiber, like the part on the left, that's actually one of the sample parts that I got here. The way that you orient your part will have a massive impact in how that part behaves. Why? Because of this diagram that you see on the lower left, right? The layers, so when you think about 3D printing, we're essentially splitting a part into multiple parts, into multiple layers. In essence, we're creating a cake of the part, right? We're splitting that part in a given direction. And the way that we'll split it will have an impact on the way that that part can actually withstand certain loads, right? So in the case of the L, if you think about that L, right, the leftmost diagram shows the L printed essentially like this. So if my, do I have a little build plate around here that I can play with? Well, let's use my, I have one, but it's a little bit far away. I'll just use my cell phone. Imagine my cell phone being the actual build plate, right? If that L is oriented vertically against that build plate, what will happen is as soon as I apply a load, let's say that I want to apply that load in the longer end of that L, the layers here are actually parallel to that load, which means that they will be much more prone to breaking and to failing under stress, specifically in that direction. So there is a directional component of the strength that is associated to the actual orientation of your part, right? The same part, that same L, if I oriented it flat against, and I have a few plating options later on in the presentation, but if I oriented that L flat against the surface so that each section of the L actually, it's a sort of a complete slice, then the force that that part will be able to withstand, for that specific load will be much higher, just because now those layers are not parallel to that load, right? The load is not being applied parallel to those layers, which means it's less likely to delaminate. What we call delaminate is essentially like the layers open between each other, and ultimately the part fails. On the other hand, when talking about woven carbon fiber, right, the considerations are a little bit different, but also similar in certain ways, right? Because you also have this, the way that you were weaving, the fiber itself will affect your end result, right? If you think about that diagram that I was showing at the very beginning of the bicycle, that layout, the way that you actually position each of the little parts that will make up your final product will definitely have an effect on the way that your part performs, right? If you don't have this interwoven layout, if you don't have a clear understanding on how these different sections are going to be presented against the force that the part needs to withstand, then you will definitely compromise your part, right? You will have different results. So in a sense, it's a similar thought process in that you really need to consider the manufacturing process before and the implications that it will have on your end part, right? So depending on how you orient your part, you will get different strengths associated to that part, and specifically on the way that the load that it can withstand. And that's also true for woven carbon fiber. You will need to change the layout and the layup of your part in order to better perform for certain stresses and for certain changes in directionality of the forces that are going to be applied on your part. So because of that, also, with 3D printing, you do have a much more complex and diverse control over the lattice, right? Because we are actually controlling how much, how dense a part is going to be. If you think about that diagram on the left, we can actually define if we want the part to be completely hollow, if we want the part to have an internal lattice that is actually going to increase the strength of the part, if we want that part to be completely solid, right, like that, this element on the right. So that control of the internal cavities is one thing that you can only do with 3D printed carbon fiber. When you're using woven carbon fiber, the control is given by the fabric layout, right? Each of these parts, each of these little segments of the frame and the way that you orient them. So it's going to change how your part performs. So, just an important thing to consider. And if you're trying to make analogies here, right? When using woven fiber, it's all about how do you control the fabric layout. When you're 3D printing carbon fiber, it's about controlling the internal lattice, controlling the internal structure, controlling the part orientation as well, because that, as I said before, and as I was showing you guys with that L example, is going to definitely affect how your end part actually performs. Now, when printing carbon fiber, we see a lot of different options from industrial to hobbyist. I would say, method falls in a really interesting category of professional printers where it's not so expensive and it does have a quite range of options. Most of them, and specifically method, does have a guaranteed spec for accuracy and other additional elements like the calibration, the user experience. So you're getting a little bit of both worlds. Because of our partnership with Stratasys, we are getting a lot of those industrial features, but in a much more, I would say, user-friendly package, right? That's one of the things that I really like about the Method platform itself. When we're talking about now moving on to the extruder setup, and I'll be getting into the actual sample parts in a second, but we are printing in the Method by using two tool heads, if you're not familiar with Method itself. So the printer has two tool heads. Here in the diagram, you see them as 1 and 2. One tool head is going to be a dedicated material tool head. The second one is going to be a dedicated support tool head. Specifically, right now, we're talking about carbon fiber. So we do have a dedicated extruder for composites, and I'll talk about why we have a dedicated tool head for that. But it's what we call the 1C extruder. You can also use the labs extruder. So if you have already have a method and you would like to add carbon fiber to your material options, you could also just buy the labs extruder and get started with carbon fiber. And the second extruder is what's going to give you the support options. For supports, specifically for carbon fiber, you can use two different types of supports, either PVA, which is water soluble, or SR30, which is our Stratasys material. And it's also soluble, but it does require an extra agent to be added to the water, and preferably to do it in a wash tank that actually heats the water a little bit. I think it takes it to about 45 to 60 degrees Celsius in order to expedite the cleaning process. But that's an important difference between Method and many other dedicated carbon fiber platforms. In this case, you actually have, and that's one of the reasons why I was showing this part, this propeller, you actually have the freedom to create really complex parts as you would expect with 3D printing, right? And at the same time, remove that support material, remove the support material, the scaffolding, let's say, that's needed to print that part easily just by dunking that part in water. Many other printers do not have soluble supports. And what that means is that essentially you're a little bit between worlds, because yes, you're 3D printing, but at the same time, you cannot really print fairly complex parts because of the limitations that you might have with the support material itself. So yeah, I was talking about the material extruders. Either for carbon fiber, you can use either the 1C extruder or our third-party labs extruder. Just to do a quick parenthesis on what that means, we actually created, and I have it here, we created another extruder that enables you to print with any third-party material. It doesn't have to be a Makerbot material. It can be any material that you want. If you want to use wood fill, and I have actually used it in the past, that's fine. If you want to use bronze fill, any type of weird composite that you would like to test out, you can do so just by adding the labs extruder to the method. The reason why we're using a dedicated extruder sorry, for third-party materials is that we wanted to create a platform that enabled you to not expose the whole system to a foreign material, right? So in this case, you're only playing with the extruder as opposed to playing with the whole printer. And I think that, I like that ability to actually have dedicated tool heads. And in a way, I see it very similar to what happens with, drill bits or a CNC, specifically with drill bits, right? We all know that you can have drill bits for wood, drill bits for concrete, drill bits for steel. They might all make a hole, but you really, really, really want to use the concrete drill bit when drilling a hole in your wall, right? And that's the same idea here. So we're creating dedicated extruders so that you have a better experience, that you have a more controlled interaction with the printer, and ultimately you get better results. And as I was saying before, for support extruders, support 2, which prints PVA, and support 2XA, which prints SR30, both of them soluble, one of them water soluble. SR30 requires an additional agent to dissolve. Now, another important thing to recognize when printing carbon fiber is that it will 100% wear out your nozzles, especially if you're using bronze nozzles, right? So, well, all of our method extruders are stainless steel, which is much more stronger. But some other components in the extruder itself needed to be replaced for the 1C extruder in order to withstand or to better stand the abrasive nature of carbon fiber. Specifically, and this is also true for the labs extruder, but the 1C extruder and the labs extruder have a different gear set. They are essentially steel gears that will better withstand the wear that's caused by just running the carbon fiber. Carbon fiber can be very abrasive, as I was saying before. When you touch the material itself, it does have this kind of grainy, almost sandpaper quality to it. And we also have, as I was saying before, the steel nozzle. So it's important to consider, again, this idea of the dedicated tool head for the material. It's not only, to give you peace of mind, but there are definitely specific hardware differences that will make a difference or will have an impact in your ability to print certain materials. Now, even though you have the option of printing with soluble supports, you also still can print with breakaway supports. So the picture on the left is, again, this propeller, but printed out with breakaway supports. Breakaway supports essentially means that we are going to be printing with, let me move the video here so that it's not in the way of the chart. We're going to be printing with a single material, and you can do that with method. It's going to save a lot of time because you don't have to toggle between the material tool head and the support tool head. However, for some more complex parts, you might run into issues when trying to remove that excess material, right? So most of the platforms of the 3D printing platforms will offer breakaway for carbon fiber. It's a good option to have, but as soon as you're starting to push the envelope a little bit to try, as soon as you try to create more complex parts, then you really want to have that option of having the water-soluble supports. And in Method's case, both PVA and SR30 work with carbon fiber. Personally, I've had a better experience with PVA, the reason being SR30. I mean, both of them are great, but PVA is a little bit easier to remove from carbon fiber. SR30 will really create a solid link between your part and the build plate. So you will have to spend the time and follow through with the dissolution process. It's a much more stable material, and it's up to you to choose. And both of them have their pros and cons. PVA, super easy to dissolve, just add water, and SR30, a little bit more complex to dissolve, but definitely much more stable for complex parts like what I'm showing just there. Overall, well, the compatibility, we can talk about that. If you have some questions, around, should I buy the Method? Should I buy the Method X? Both Method and Method X will work with carbon fiber. However, the idea is that it's not an idea. Method X actually has a wider range of temperature, specifically for the build chamber. So Method X will go to 110 degrees Celsius, which allows you to print with much more complex materials such as polycarbonate and ABS. It's actually a physical difference in the hardware. The heaters inside of the printer are, well, twice as many. And because of that, it actually draws twice as much current. So with Method, you're talking about 400 watts. With Method X, when actually using the full capability of the build chamber, you're going all the way to 800 watts. So for that, it's also important to consider some of the electrical requirements. Both go to a standard electrical output, but you don't want to put anything more than the Method on that output. We've had a fun time sometimes when testing them out in the office. If you put too many Method X's out in a single breaker, yeah, you can definitely make it pop. So going back to the material itself, and as I was saying, we've talked about nylon carbon fiber as a whole, But I mentioned at the beginning that we have two types of carbon fiber. We have nylon 6 and nylon 12. And each of them has different properties, different implications, and different best practices. Initially, we introduced our standard nylon carbon fiber. And it's actually not just nylon, but it's nylon 6/66 blend for a incredibly high strength to weight ratio and heat resistance, right? It's super strong. The heat deflection temperature, it's way higher. It's actually higher than nylon 12. It goes all the way to 184 degrees Celsius, has 110 megapascals in tensile strength, and also the tensile modulus is way stronger. However, nylon 6 is much more sensitive to humidity changes. And this is true not only for the printing process, which is much more easy to control with method, because as I was showing you guys before, we have material base that enclose the material and keep it nice and dry throughout the printing process. We have the heated chamber that's also enclosed that keeps it nice and dry as it's being printed. But once you take the part out, you still have to, with nylon 6, which we refer to just as nylon carbon fiber, you do have to consider the humidity levels that will be, that you will have on your part as soon as it's out of the machine, because those values change as the humidity changes in the environment. And I've seen that with many of my parts. So it's definitely stronger if you can control the environment at which it will be, or in which your part will be used. If not, then definitely defer to the nylon 12. Now, nylon 12 is much easier. It's not as finicky as of a material. And it's seriously, I keep saying this, and I don't know if you guys will believe it, but it's definitely my favorite in Makerbot's portfolio, just because of how easy it is to use and how great results, and I'll show some of the parts that I have here, how greater results you can get with it. So if you see, let me stop sharing for a second. All right. And I'll try to have the camera to focus on this one part. Can you do it? Come on, you can. Will I do it? Out of focus still. But anyways, the quality of parts that you get with nylon 12, there we go. It's just freaking unbelievable. It's hard to distinguish the layer lines in the parts. It's hard to actually, tell that this part was 3D printed. And that's one of the very impressive things for me on nylon 12. It's like both super easy to print, super stable when printing, and not only that, but after the fact, the part remains incredibly strong, incredibly light. It definitely doesn't have, on paper, the same performance. Well, and it's true, it's not only on paper. It definitely has a little bit less of, heat deflection temperature. It does have a little bit lower tensile modulus, but it might just be enough. So that's one of the questions that you need to ask yourself. Like when I'm printing my part, and this is a gripper that I designed last year, but as I'm creating my part, what is the actual need that I have for strength in my parts? Going back to the deck here. Here we go. So nylon 12 is, as I said, it has a little bit of a lower heat deflection temperature, a lower tensile strength, but it's much more stable a material. If you're getting started with carbon fiber 3D printing, definitely default to nylon 12. It's much more stable material while keeping an incredible strength throughout. So not as strong, but definitely pretty strong when compared to any other materials. And this is what I was talking about before, right? Nylon 12, as many polymers, it can degrade over time as it's exposed to the elements, but it's going to stay in a much more stable way, like that line of tensile strength versus moisture content shows. Whereas just nylon carbon fiber, essentially the nylon 6 carbon fiber composition, will degrade a lot and really fast if it's exposed to higher levels of humidity. So that's definitely something to keep in mind when getting started. And personally, I would say overall, it's just a much better experience to print with nylon 12. And not only a much better, it's the best. I mean, incredible material. I cannot say enough good things about it. And of course, it's with method, you're not just getting the one material, and that's one of the things that we've been really pushing for. It's not just printing with carbon fiber, it's not just printing with ABS, it's printing with a range of materials. And what I was saying before, it's not only the range of materials, but having the dedicated tool heads for that. So, initially I was like a little bit reluctant of, hey, do we really need all of them? Do we want to just make the one that actually covers everything? But the truth is that as you print and as you get exposed to many more materials, you really want to have dedicated tool heads, because it just makes a cleaner process. It makes it easier for you. It's easier to maintain. It's just like having your proper drill bits. You're just using the wood for wood and the metals for metal. I don't know. It gives me peace of mind. And we have quite a range of them. So depending on the type of filament and depending on the type of polymer that you're trying to print, we definitely have a solution for that, whether it be the more basic polymers or more advanced polymers, or in the case of carbon fiber, the composites, right? As you're preparing your files for printing, you will, this is a window that you will get with Makerbot Print. And you can also use Makerbot Print without having the method. That's completely fine. You can download the software and play with it a little bit, see what are the options there. But you will have to select, first off, two things: the model extruder, which in this case is the 1C, as I was saying, our dedicated carbon fiber extruder. Then select whether you're using nylon carbon fiber or nylon 12. If you're connected to the printer wirelessly, then the software will do that for you automatically. So as soon as I drop my material into the drawer, the printer will recognize it and will make the necessary adjustments on the back end in the slicing software. The second thing to select is the support extruder, also true, also auto-detected on the printer. As soon as I drop my material in the printer, then the printer will know what I'm using and will make the necessary adjustments. But if you don't have it, then you just select whether you're using the support 2 extruder, which works with PDA, or the support 2XA, which works with SR30. That's only available for Method X. And finally, the print modes. For carbon fiber, we have 2 print modes. It can either be balanced, which defaults to a 20% infill, or solid, which, well, prints it solid or as close to solid as possible, making the lattice as dense as possible through each of the layers. Now, another thing to consider here as you're preparing your file, and these are the 2 previews of the same file. So my propeller here, you can see, I'll just play with it a little bit. It's so, I really like the reflections that you get, right? And that's only possible once you get a proper layer definition from the printer. But anyways, with carbon fiber, the perch tower, it's also going to look a little bit different. So you get this bow-like shape that essentially allows us to better clean up the tool heads every time that we toggle between materials. So when using soluble supports and when using those dual tool heads, you will want to clean, well, not you, but the printer will clean the tool heads between passes so that you don't cross-contaminate one material with the other. It'll print all of the layer on the material, so the carbon fiber, and then it'll go to that corner, so to this, what we call the perch tower, purge itself, and then toggle over to the support material and print the remaining section of the support material. The reason for that is just, again, to keep your parts as clean as possible and make sure that you get the best results as possible. It is a little bit bigger. If you have used ABS in the past, the perch tower is going to be a little bit bigger than ABS. That's because of the extra, there's a little bit of an excess material that sometimes can drop from the extruders as you print. That's why the perch tower will grow a little bit. So in case you see that, that's the reason why. But overall, why would you print with carbon fiber? It's just all about geometric freedom, right? It comes down to being able to print complex parts and get accurate results. It's also about having a minimum setup, which is what Method offers, which I think it's true, right? It's just easy to use. As I was saying, you connect your printer, you put your materials in, and the printer essentially knows what to do as soon as you connect to the, to our Makerbot slicing software. It's also low cost. So comparatively, if you were to manufacture carbon fiber layout, like the frame that I was showing before, it's just much more expensive because each of those sections has to be applied by hand, right? I don't know if you have seen any videos of bicycle frames being built, but it's definitely a labor-intensive process. And also the material choices, right? The idea that we're not talking here only, today we're talking only about carbon fiber, but the offer and the promise with the platform is that you're not locked into a single material. So today I might want to print with carbon fiber, but tomorrow I will want to use and need to use ABS, right? So this idea of being able to toggle back and forth between different materials is what makes it really, really powerful. We talked about some of these numbers. Of course, if you guys want some specific facts on the performance of the material, we can definitely share them out. We've done a lot of testing, and if you've ever joined some of our material showdowns, that's another really interesting thing where we just test out the, some of the questionnaires are coming up. So do you currently have an application for 3D printing with carbon fiber? I mean, are you actually actively thinking about using carbon fiber? I'll give you guys some time to answer. But as I was saying, we do have quite a comprehensive set of tests. Sometimes we do them live. I don't know if you joined any of those, but essentially we destroy some of our samples trying to figure out, what is the material that will perform the best? And unsurprisingly, so far, nylon 12 carbon fiber has definitely, outdone all of the materials. Okay, so most of you do not currently have an application for 3D printing with carbon fiber. I'm sure that once you get the printer, you will have one. Carbon fiber, it's just, and I have another project that I might share for just a second here. Yeah. So this guy here, I'm actually printing a replacement pedal for a bicycle. And you can see, let me just open, actually, let me stop sharing so that you can see the video in a bigger format. But the quality of the quality of the part and how tight, and actually I might need my hex key here to open this guy up. But this is actually a threaded cap that goes into the carbon fiber part without any hiccups, right? So just the tolerances that I'm able to use and the fact that I'm actually able to stand on this part and I'm pushing it, right? I'm trying to test out how much weight will the pedal actually support. So I'm about 180 pounds. Not super heavy, but if you split it, it's about 90 pounds applied on this single pedal. And so there's an impressive combination of the print quality and also the strength of the part. And again, it comes down to being able to have that geometrical freedom. So being able to print the hollowed out parts, you can see how the strap itself follows through the pedal because I got some carved out sections in there. So fairly complex parts that I'm able to print without any hesitation because I have the soluble supports, right? Another really good example of an assembly here I was showing to you guys before. And again, it all comes down to having a proper, how much will the pedal cost to print? Material-wise, we are talking about what, like maybe $10, $15? So yeah, it's not a lot. Each spool, I'm not sure about the proper price of the spool. I want to say it's $70 for a spool, and the spool is about £1.50, I want to say. I'm not sure, but the actual cost of this pedal is less than $10. So definitely cost effective, especially when compared to some of the metal parts, right? If you're trying to replace, and this is what happened with this part specifically, does that include the support material cost? Yeah, just about. I mean, it's about the same price for both spools of support material and the material itself. But it was definitely what they were trying to do with this part. They were trying to replace a metal part with a carbon fiber part. And this part was originally thought to be a machine part. If you think about these being machined out of steel or aluminum, you're easily talking about close to a couple of $1,000s between the material cost and the print time. I'll start running through some of these questions because I want to get to some of those too. Or let's lightweight ratio, strength to weight ratio. Okay, let me finish this this section and then we'll jump right into the questions because I'm excited to see that you guys have so many of them. Just want to make sure that I cover everything here. All right, we'll talk about the examples here with method. There's a bunch of reasons why we could talk about method and what's the benefits of it. It's about the heated chamber, it's about the open platform, it's about the soluble supports, but it all comes down also to the amount of materials that you have. 24 and counting, really excited for that. It's just the amount of materials that we've been able to add to the platform. For me, it's really impressive, and not only impressive, but also exciting. And finally, it's about carbon fiber. So I'll jump into the questions for you guys. And while I do so, I'll also ask Alejandra to ask you if you have any, if anybody's interested in talking to sales. There's a promo running right now for the Method and the Method X platform. So if you want to get a deal out of it, it's also a good time to ask. But I'll start jumping into the questions. Let me stop sharing here so that you guys can see only my video. And I'll try to run through some of the questions, and I'll also thank Alejandra if she can ask some of them as we go. Which tool heads come standard with the Method X carbon fiber? You will be getting the 1C extruder, so this guy right here, and the 2XA extruder. I don't have it with me right now, but no, it's not the 2XA. But you have the 1C, which prints all of the composites, and the 2XA, which prints SR30. It seems the parts you presented were printed using chopped carbon fiber. How about if I want to print parts with continued carbon fiber reinforcement? Yes, so you can use our labs extruder to print any material that you want, including some of the specialty single thread carbon fiber. We don't provide that, but if you have it, and if it's 1.75 millimeters in diameter, you can definitely run it through the labs extruder. What modeling software for beginners and advanced do you recommend to design prototypes before bringing it to Makerbot print? I've had a good success with Fusion 360. Personally, I like to use Rhino, but I know that that's a little bit of a specialty thing for designers, perhaps. Is the nylon carbon fiber an option for outdoor parts? Sounds like 6 would not be recommended. Correct. Would ASA? Yes. So nylon carbon fiber, I wouldn't use it for outdoor parts. Definitely ASA might be a better material. Nylon on itself, without being nylon carbon fiber, could be another good option. ASA, it's much better to withstand UV light, right? So it all depends on what you're using. Also, PETG can work really well if you're going to expose your parts to higher humidity, or even like directly water. Is there any post-processing techniques with carbon fiber material so that the part layers fuses with each other, giving it a more smoother finish on the part? Yes, and actually that's a good question, because the printer itself has, it's not only, and I'll move the camera a little bit to show you guys the printer. I'll come back to the parts in a second. But with the heated chamber, it's not only that you're continuously heating your parts. Oh, I'm too close, sorry. But not only are you being able to heat up your parts as you print, there's also an annealing feature on the printer. So you can put your parts back into the printer after you're done and essentially reheat them. And it'll, the chamber itself will act as an oven of sorts. It'll reheat the part, it'll create a better adhesion between the layers. And the main goal with that feature is not necessarily to change the look or the aesthetic of your part, but rather the actual bonding between the layers. So yeah, that's one direct benefit of the heated chamber. You can use it just to reheat your parts and get a stronger layer addition on them. Did you have to do a spool change during printing? No. If you're using just carbon fiber, no, you just get started with carbon fiber, and that's it. So the printer itself will manage both materials, the support and the carbon fiber material, and it automatically toggles back and forth between both of them. Had you had any luck gluing parts? I haven't tried gluing parts. I've usually just used fasteners, like in this assembly. I'm not sure if you mean like parts that break, Jeffrey, if you're talking about parts that broke off or something like that. Are any of these designs available for us to print? No, I should actually upload some of these to Thingiverse, but I haven't. I'll think about that and then send them out for sure. We tried to print parts with Polymaker PA6 carbon fiber and have had some issues figuring out the best printing temperature. Also, the printed parts didn't stick to the platform, so we put the tape on the platform to get better adhesion. Otherwise, we had the filament distributed to it. Is it necessary to print with support material? I would say it depends on the complexity of the part. Like, for example, this part I printed without any supports. Essentially, it was just this through holes that might have needed support. So not necessarily, but for some more complex parts like these, yeah, you should consider printing with supports. Can we get a copy of the presentation you provided? Yes, for sure. We'll be sending out a copy of both the webinar and the recording. And we're actually running a little bit low on time, so I'll try to go through some of these fairly fast. Best way
Hi,
to
Felipe. I have a lot of questions too that I've been gathering throughout. So let
I'm
me just
sure.
jump in and ask you a couple. How does that sound?
Perfect.
Do you use any adhesives on your base plate when printing?
I don't like to because it does make it a little bit messier, but you can definitely use essentially a glue stick for some of the parts. When you're using carbon fiber, I haven't had any issues with it adhering to the build plate so far, but if you're seeing issues, you can use a glue stick and that will definitely help.
Okay, and when you were talking about nylon 6, can you mill or drill this material?
Yes, both of them, both nylon 6 and nylon 12, you can. Milling it, it depends, and you know, for that you will want to make sure that your parts are completely solid. Drilling it, yeah, but it also, I mean, it's just considering the end result that you will need. Personally, I would default to nylon 12, but it all depends. And for sure, if you're thinking about milling, do consider or do make sure that your parts are solid. Otherwise, you will have issues as soon as you hit the hollowed out part of your parts.
Okay. Do you have a performance comparison of PBA versus SR30, specifically ease of removing supports for nylon carbon fiber?
I don't have a specific spec or comparing both of them. I will talk about my personal experience. SR30 will come out in chunks, right? But it really wants to stick to carbon fiber. So the first layers are going to be really hard to remove from it. PBA might be more straightforward. However, PBA, it's a little bit of a more finicky material. Okay, straight answer, PBA or SR30? PBA, I would default to PBA.
Okay, and now how long or how much filament usage does each tool head last with? Just, you know, before the nozzles wear out.
Yeah, I can speak for this machine. I mean, I don't have the specific hours, but it lasts for, I don't know. I've been running these tool heads for the past year now, and I print quite heavily on it. Easily, you can think about, I don't know, 20, 50 rolls of filament before the nozzles wear out. And even if they do wear out, specifically for the labs extruder and also for the 1C extruder, we have, and I'll try to bring it closer to the camera here, they come with a set screw here that allows you to remove the nozzle. So the nozzle is replaceable and you can just get a new nozzle and keep using the same extruder.
Okay. Is there any post-processing techniques with carbon fiber material so that the layers fuses with each other, giving it a smoother finish on the part?
Yeah, I think I touched on that one. It's the annealing process. So you can definitely put your part back into the printer. I think it's on settings, if I'm not mistaken. No, advanced. Yeah, so if you go to, on your printer, you go to, and let me jump into this view here for a second, because the annealing process is definitely a really powerful option if you're looking to strengthen up your parts. Here we go. Just moving the camera a little bit so for you guys to see. So if you come to, let's make it closer. Oh, there we go. If you come to advanced, and then under advanced, you can see anneal print. What this will do, and I was describing it before, but maybe it's better to just show you directly. It'll start heating your part and essentially use your heated chamber as an oven to reheat the part and get a better layer addition with it. So really, really, really useful feature to have.
Okay, and now, what is the concentration of carbon fiber in nylon 6 and nylon 12?
I don't have a specific number for that. I would need to go back to our materials engineer and ask for that. I don't have an answer for that.
Okay, and can you recommend settings on the method to print with carbon fiber? I've had a couple people
Yeah,
asking
the
for that.
standard, so the default is about 60 degrees Celsius for the chamber. If I'm not mistaken, and I'll just not to make things up, I'll open print now. But I would default to the settings that we have on Makerbot Print. If you just select carbon fiber or nylon 12 carbon fiber, it will give you the best settings that we found so far and makes it just really easy for you guys to print with it. But let me share my screen real quick. Sharing Makerbot Print. Okay, so I've got my part in there, right? And then I'm going to go to print settings, select my extruder model 1C, select nylon 12 carbon fiber, and this will automatically adjust my settings here. So for the extruder, the idle temperature is going to be 180 Celsius, and the print temperature is going to be 270 Celsius. The default infill density is 30%, and the chamber temperature is 80 degrees Celsius. Now, this is using a method X. If you're using a regular method, then it'll default to the max chamber temperature available on the method, which is 60 degrees Celsius.
Perfect. And for one last question, since we're running out of time, can the annealing process bake moisture out of any nylon part that was exposed to moisture?
It's a hard question because it's not a straight yes. It'll definitely help, but I would say that depending on the part, it might be better just to leave it outside for a day or two, because the annealing process will take you up to 60 degrees Celsius. And thinking about just the water boiling temperature, you would want to go to 100 degrees. But if you go that high, you can compromise the part itself. So it will help. It depends on how much water you got in there. So I definitely would say that the longer that you leave it in there, the more moisture that will be evaporated from the part. But it's definitely a really good feature to use for some of the parts after they've been washed, after the soluble support has been removed. But I would say again, if you're looking to get that, I hopefully that we've covered a lot of different topics today. If you're looking to get a printer, if you're trying to get started to start the year with a method, it's definitely a good time to do so. It's just the fact that we have that promo, and I keep thinking about the first time that I got my printer, but 25% off of the method, it's actually a pretty good deal. I don't know how many of you actually chose to speak to a sales representative, but it is it's not only 25%, but you're getting 25% off and 2 spools of carbon fiber right now. So I would definitely look into that. If you're considering getting the printer, talk to sales. I'm sure that they can set you up with a really nice setup. I don't know if you want to bring that question again for anybody who might have missed it, Alejandra, but yeah, it's just a great platform to use and a fun one for that. But yeah, I think that we've covered most of the questions. Anything else that you guys would like to know, do send us a note to hello@makerbot.com. Let me see if I can cover a few more. Or Felipe@makerbot.com. That's FELIPE@makerbot.com. And we'll be more than happy to answer those. But yeah, in the meantime, thank you guys so much for coming today. Really excited to have you guys here. And yeah, any additional questions that we haven't covered today? Annealing, do you have the data strengths on? Yeah, there's quite a few. So we'll try to answer some of those through email, but hopefully this was informative. Thank you guys so much for coming this morning. And yeah, I hope you have a fun time printing, and I hope you are excited as we are to use this material. Again, it's just, for me, it's been a blast. Thank you so much. And we'll talk again soon. Have a good one.